Today we will discuss the topic of physiochemical properties of drug molecules. This topic is covered in Unit 2, that is states of matter, properties of matter. Now, physiochemical properties of drug molecule. What are physiochemical properties? These are the physical and chemical properties of the drug molecules, which are important in the early requirement of the product formulation. It provides better understanding of interrelationship between molecular structure and drug action. These properties are additive and constitutive. Additive means they are derived from some of the properties of individual atoms or functional group within the molecule. Constitutive means they depend upon the structural arrangement of atoms within the molecule. For example, optical rotation. It is an additive property. The physical properties of drug molecules along with simple chemical derivatization and degradation reactions plays an important role in drug design, in designing of analytical method. Now, first physiochemical property we will discuss is refractive index. Now, refractive index क्या होती है? As you have already studied in your previous classes, that refractive index, which is it is one of the physiochemical properties of the drug substances. The refractive index is the ratio of the velocity of light of a given wavelength in vacuum to the velocity of light of a given wavelength in the selected medium. It is denoted by n. N is equal to C upon V. Okay, when the light ray of the light passes from air into the liquid, its direction is changed, and the change in direction is called as refraction. Now we will discuss about the Snell's law. It is a law. It states that is n is equal to sin I upon sin r, where I is the angle of incidence and r is the angle of refraction. Means the Snell's law describes the relationship between the angle of incidence and the angle of refraction. Now this diagram, it describes the refraction of light when the light travels from one medium to the another medium. According to the wave theory of light, the ratio of the sine of angles of incidence and refraction is identical to the ratio of the velocity of light into medium. Thus, n is equal to sin I upon sin r. We can also mention it as velocity of light in air upon velocity of light in liquid. Okay, when the ray of light passes from a rarer to denser medium, the law of refraction is given by this equation, that is sin I upon sin r is equal to n2 upon n1, where n2 is the index or refractive index of the denser medium and n1 is the refractive index of the rarer medium. Now, how the refractive index is measured? There are various methods of measurement of refractive index, which is measured by the help of refractometer. Now, there are various refractometers you can see in the list. First one is Abbe's refractometer, second is Pulfrinch refractometer, third is immersion refractometer, fourth one is V block refractometer. Now, first of all, we will discuss about the Abbe's refractometer. This diagram shows the Abbe's refractometer. The Abbe's instrument is most practical and widely used refractometer. The Abbe's refractometer was the first refractometer to be commercially available, and it is used to determine the refractive index of the liquid. Now, principle is that it is based upon the principle of measurement of critical angle. Means in Abbe's refractometer में हम क्या करते हैं, मेजर करते हैं critical angle. ये डायग्राम है Abbe's refractometer का. ओके, इसकी वर्किंग मैं आपको एक्सप्लेन करती हूँ. वर्किंग में क्या है, द लिक्विड सैंपल इज प्लेस्ड ऑन द थिन लेयर. लिक्विड को हम थिन लेयर में प्लेस करते हैं बिटवीन एन इल्यूमिनेटिंग प्रिज्म एंड अ रिफ्रैक्टिंग प्रिज्म. ओके, द रिफ्रैक्टिंग प्रिज्म कंपोज्ड ऑफ ग्लास having a high refractive index. The upper prism is mounted on a bearing which allows it to be rotated by the means of the lateral arm, which is shown by the dotted lines. The lower prism is hinged towards the upward to allow the separation for cleaning for introducing the sample. Means the sample, इसमें क्या करते हैं, हम sample को place करते हैं two prisms में. Okay, one is illuminating prism and second is refracting prism. Now it's working. A sodium lamp is projected through the illuminating prism, whose lower surface is ground or roughed, so that each piece point on its surface generates light rays in all directions. The radiation is refracted at the interface of the sample and the smooth surface of the prism. After that, it passes into the fixed telescope. The refractive index of the substance is a function of wavelength. If the light source is not monochromatic means the light is scattered and the shadow boundary is not well defined. Instead of seeing a sharp edge between white and black, you will see a blue or red blurred border. In most cases, the measures are very inaccurate. Okay, the position of the amici prisms can be adjusted to correct the dispersion. Two amici prisms that can be rotated with respect to another serve to collect the divergent critical angle rays of different colors into a single white beam. A telescope is rigidly fixed in the sector which is fixed to upright of base so that the axis or sector coincides with the rotation of the prism length. Okay, the refractive index is read through the eyepiece at the upper end. Now second refractometer is Pulfrich refractometer. You can see the diagram. Pulfrich refractometer. Here light source and sample is placed, and this is the measuring prism, then telescope. Okay, Pulfrich refractometer is a design after Abbe refractometer that becomes commercially available in 19th century, and it is another type of critical angle refractometer. Means principle is measurement of the critical angle. The glass prism with a high refractive index comprises the two planar polar faces which are perpendicular to one another and are placed so that one of them is vertical and other is horizontal. The substance of which the refractive index is necessary, the substance is placed on the horizontal surface, and in case of liquid, a glass cell cemented on the prism so that to contain its face. A beam of monochromatic light is incident, okay, at the right angle. The angle of refraction is measured with the help of telescope. Now this is an equation where n is equal to under root n square g minus sine square I. Okay, where n is the refractive index, I is angle of incidence, okay, and refractive index of glass, that is Ng. Now third is immersion refractometer. Immersion refractometer, it is similar to the Abbe's refractometer, but it lacks the illuminating prism. Means इसमें illuminating prism नहीं होता है, ठीक है. Here it consists of measuring scale, refractometer, measuring prism, light source, mirror. In this refractometer, lower surface of the refracting prism, lower surface is dipped into the sample. Here जो इसका lower surface है उसको sample में dip करेंगे sample solution में to make a measurement. ठीक है, तो एक mirror लगा है इसमें जो help करता है to direct the natural light onto the surface of the prism of measurement. Okay, grazing incidence of light fall on the prism. ओके, क्रिटिकल रे डिटेक्टेड बाय द फिक्स्ड टेलीस्कोप. टेलीस्कोप क्या करेगा, हमारी जो क्रिटिकल रे है उसको डिटेक्ट करेगा और रिफ्रैक्टिव इंडेक्स को कैलकुलेट करेंगे हम. इमर्शियल रिफ्रैक्टोमीटर्स ऑलवेज ऑपरेट एट द टेम्परेचर ऑफ द लिक्विड. नेक्स्ट इज वी ब्लॉक रिफ्रैक्टोमीटर. वी ब्लॉक रिफ्रैक्टोमीटर, इट इज डिजाइंड published in 1941. You can see the diagram, that is V block refractometer. Here is the light source, then slit, then a sample, then after that telescope to detect the refractive index. Okay, in V shape cell cut into a rectangular glass block. The cell walls are perpendicular. The cell is filled with the liquid. Okay, liquid को हम fill करेंगे जहाँ पे आपको sample mention है. The beam of light enters into the sample and is refracted twice to two perpendicular cell walls. The angle from which the light leaves the refractometer block is a function of refractive index. Means हम वो angle measure करेंगे जहाँ पे light हमारी refract हो रही है. That is the refractive index of the sample and the glass. Okay. Now what are the factors which affect the refractive index? There are various factors, that is temperature, wavelength of light used, pressure. Now there are various applications of refractive index. First of all, I have told you that it is mainly used to identify a particular substance, means to confirm its purity, to measure the concentration, okay, to determine the concentration of drug. In the pharmaceutical industry, we use the refractive index to measure its purity. Second is to calculate the focal power of lenses and dispersive power of the prism. Third is it also applies to estimation of the thermophysical properties of hydrocarbons and petroleum mixtures. Fourth is it is used in the examination of organic compounds, and in veterinary medicines also it is used to measure the total plasma protein in the blood sample or in the urine to measure its specific gravity. It is also used to determine the amount of sugar in the sugar solutions, and in general to determine the total solids in fruit juices. Okay, these are the application of refractive index. Okay, you can see. Now next physiochemical property is optical rotation. Students, these physiochemical properties you have already studied in the lower classes. Okay, I am just revising all this property. Now optical rotation. Optical rotation क्या होती है? Optical activity you have heard ना? Rotation of plane of polarized light. Okay, means many substances possess the inherent property to rotate the plane of polarized light. Okay, this activity is called as optical activity. Now optical rotation is the angle at which the plane of polarized light is rotated. Okay, students, the plane of polarized light is rotated towards left side and towards right side, means anti-clockwise direction and clockwise direction. Okay, you have heard about the dextrorotatory and levorotatory, na? When the plane of polarized light is rotated towards the right, means in clockwise direction, it is called as dextrorotatory. You can show it by the plus sign. Levorotatory, when the plane of substance have the ability to rotate the plane of polarized light toward the left or in anti-clockwise direction. So this is denoted by minus sign. Okay. Now you can also study the measurement of optical activity. Okay, now this optical activity is measured by the help of polarimeter, which is a device which measure the degree of rotation of plane of polarized light. Okay, through an optically active material. Now in instrumentation you can see the diagram of polarimeter. It consists of the light source, then polarizer, then analyzer, then sample tube where the sample is placed, and then detector to detect the optical rotation or angle of rotation. Now students, you can also study the procedure of measurement of optical activity. Okay, this here when the light is passed through a polarizer, only light oscillating in one place will leave the polarizer. The plane polarized light is introduced into the tube which contain the sample. Okay, if the substance is optically inactive, the plane of polarized light will not change its orientation, but if it is optically active, the plane of polarized light will be rotated in either direction, in clockwise direction or in anti-clockwise direction. Okay, for clockwise direction the rotation is defined as positive, okay, means dextrorotatory, and for anti-clockwise direction it is denoted by the negative sign, means levorotatory. And there are various factors which affect the optical rotation. Okay, here for the given compound, the extent and direction of this rotation depend upon the orientation of the molecule in relation to the beam. Okay, how the molecule is oriented, and second is direction of beam on the molecule. Okay, third are the physical properties of crystal, then thickness of the crystal, then mass density of the crystals, then wavelength of the light used, and for seventh one is temperature of the solution, means what is the temperature of the solution of which we are going to measure the optical rotation. Now there are various applications of this optical activity. Okay, first of all, in identification and determination of optically active compounds, means which are dextrorotatory and which are levorotatory. Second is in the sugar industry, then in the chemical industry it has many uses. Okay, then in food, beverage, pharmaceutical industries, optical activity has many applications, and polarimetry is used to in remote sensing applications. Okay, these are the applications of the optical activity. That's all for today. Thank you.